Hi everybody, today we will see what dynamic programming is, the ways to solve such problems using recursion, memoization and tabulation. We will start with a simple problem, the Fibonacci series, and solve it using a basic list approach and then jump into other techniques to tackle this problem. So let's define what Fibonacci series is. It is the sequence of numbers such that any number except first and second is the sum of the previous two. Following is the Fibonacci series. First and second number in the series are the base cases. Next number, that is 1, is the sum of the previous two, that is 0 and 1. Next number, that is 2, is the sum of the previous two, that is 1 and again 1. Thus, conceptually, we can say the number in the Fibonacci series in position n is the sum of the numbers in position n-1 and n-2. Let us first visualize the solution using a simple approach. We will use a list to solve this problem. Say if we want to generate the sequence of numbers of length 8, then we will define the list of the same size. Remember, the list index starts from 0. Let's define the base conditions in the list and then proceed with the very next position, that is number at index 2. By definition, it is the sum of the previous two numbers, that is number at index 0 and 1. Similarly, the next number at index 3 is the sum of the previous two numbers, that is number at index 1 and 2. This pattern continues for the rest of the sequence. To implement the Fibonacci series, I am using Python as the programming language and the Jupyter Notebook as an IDE. You can use any IDE of your choice. Idea remains the same for the rest of the programming languages as well. So let's jump into the code. Let's first define the function. This function is going to accept one parameter. Let's define the list now. Say fib. Now I'm going to define the loop. Here I'm defining the range as num plus 1, since as we know, like index starts from 0 and I want to print the value of the index. Now let's define the base cases. So if I equals 0 or I equals 1, then we know we hit the base case. Then we will going to insert the same, we can say, index as the value. If that is not the case, then we want to go with the definition of the Fibonacci series, that is on the ith index we want to add the last two numbers and finally return the result. Okay, so let's call this function. I just write one, it can be fib and then fib1, say like number at index 7. Okay, so I need to compile it again. So yeah, that's how it is. Let us see if we can refine our solution in terms of space complexity. Let's define another function, and here in this function I will try not to use the list. So as we already know, like what are our base cases, so say like first number would be 0, second number would be fourth one. Now again let's go and iterate over the range. And now notice that I am here writing num minus 1, since we already have two numbers already in the sequence. So that is the reason I am writing it as num minus 1. Now notice here, so I am assigning the numbers in the same statement. So number 2 would be equals to number 1, and number 2 would be number 1 plus number 2, and then return the number 2. Okay, so this will do the trick. Let's try and execute it. Let's try with the same value, and we are getting the same result.